Hi, this is Ma'am Clarence and welcome to today's lesson. Today we're going to learn Chapter 1, Lesson 2, or the limit laws. So our goal for today is first to illustrate the limit laws and second to apply the limit laws in evaluating the limit of algebraic functions such as polynomial, rational, and radical functions. Now we have here the following limit laws that we will learn for today. Now take note, the limit laws state that for C and K, which are real numbers, so we have limit of f of x as x approaches c and limit of g of x as x approaches c exist, and n here is a positive integer. Now, the 9 limit laws are true if the following situations above are also true. So we have the various limit laws, the constant rule, the identity rule, the power rule, the root rule, the constant multiple rule, the sum rule, the difference rule, the product rule, and the quotient rule. Now we will learn all of this one by one. Let us start off with the constant rule. The constant rule says that limit of k as x approaches c is equal to k. Or in other words, it tells us that the limit of a constant is equal to the constant itself. Our constant here, take note, is k. C is the number that x approaches. Now, according to this rule, if our function is composed of a constant only, then the limit is also that constant. Let us look at some examples for it to be clearer to us. We have here, number 1, the limit of 5 as x approaches 0. Now, let us first identify our k and c. Now, k here is equal to 5 and c is equal to 0. Now, according to the constant rule, our answer here should be k. So, our k here is 5. So therefore, the limit of 5 as x approaches 0 is also 5, or that is equal to the constant itself. Second example, the limit of -1 as x approaches 2 is equal to what number? Again, using the constant rule, we identify which one is k, or our constant. Here again, our constant is -1. Take note, 2 is our c. So our answer here should be k, or that is equal to -1. So the limit of -1 as x approaches 2 is -1. And the third example, we have limit of 0 as x approaches -1. Again, let us identify which one is k, and that is 0. So since k is equal to 0, therefore the limit of this function, or this constant function, is 0. Clear? Now let's proceed to the second limit law, or that is the identity rule. According to the identity rule, limit of x as x approaches c is equal to c. This simply means that the limit of x is equal to c. Okay, you call this the identity rule because the given function here is only x. Now, whatever value x approaches here, that is your answer. Take note, this rule is only applicable to the function x. Now, if you have 2x, 3x, -x, this rule will not be applicable anymore. We will use another rule which we will learn later on in this lesson. Now, we have some examples. Limit of x as x approaches -3 is equal to blank. Now, again, let's go back to our identity rule. According to identity rule, the answer here, or the limit, should be equal to c. Now, in this example, we have to identify which number is c. Now, that is -3. Now, Using the identity rule, the limit of this function or this expression is -3. Next, we have limit of x as x approaches 7. Again, using the identity rule, let's identify which number is c. So that is 7. So therefore, the limit of this expression is 7. Next example, limit of x as x approaches 4 is equal to blank. Again, let us identify what number is or represents c. In this example, that is 4. Therefore, the answer to this limit or the limit of this given expression is 4. Okay, so that's limit law number 2, the identity rule. Next, the third one, we have the power rule. According to the power rule, the limit of f of x raised to n as x approaches c is equal to the limit of f of x as x approaches c raised to n. Or, in other words, this means that the limit of any function raised to a power n or an exponent n is equal to raising the limit of the function to a power. So, some examples, we have limit of x squared as x approaches to -1. So what we're going to do here is we take out the exponent, which is 2, so that what will be left is limit of x as x approaches -1. Then we will place the exponent as an exponent of the whole limit. So, if we have this expression, this means that we can now use the identity rule. Remember, the identity rule tells us that if we have limit of x as x approaches c, then the answer will be c. So, limit of x as x approaches -1 is -1. Then we raise -1 to 2, or that's -1 squared. -1 squared is -1 times -1, or that is equal to 1. Again, we take out the exponent and make it as the exponent of the whole limit. So we simply take out the exponent and make it as the exponent of the whole limit expression. Then we use the identity rule to get the answer here, which is -1. Then we raise that to our exponent, which is 2. So -1 raised to 2, or -1 squared, is +1. Another example, we have limit of x raised to 4 as x approaches 2. Again, we take out this exponent and make it as the exponent of our whole limit expression. So, limit of x, we take out the exponent 4 as x approaches to 2. So, this whole expression can be solved using, again, the identity rule because we only have x as our function. Now, the limit of this whole expression is equal to c, or that is equal to 2, using the identity rule. Now, we raise that to our exponent 4, so that's 2 raised to 4. 2 raised to 4 is multiplying 2 by itself 4 times. So that's 2 times 2 times 2 times 2. So 2 times 2 times 2 times 2, or 2 raised to 4, is equal to 16. So the limit of x raised to 4 as x approaches 2 is 16. For our third example, we have limit of x cubed as x approaches -4. Again, using the power rule first, we take out our exponent and make it as the exponent of the whole limit expression. So that will be limit of x, then take out our exponent 3 as x approaches -4. So, limit of this expression using identity rule now is equal to 4. So, negative 4 raised to 3, that is negative 4, times negative 4 times negative 4, or multiplying negative 4 by itself 3 times. So, negative 4 raised to 3 is equal to negative 64. So the limit of this whole expression, limit of x cubed as x approaches negative 4, is negative 64. So that's our third limit law. Let's now move to the next one. That is the root rule. So the root rule is basically just the opposite of the power rule. So instead of raising to an exponent, here we take the nth root, okay, nth root of the given function. In other words, the limit of a radical function is equal to the nth root of the limit of the function. Okay, so to explain this further and to illustrate it clearly, let's have some examples. So first, we have the limit of square root of x as x approaches 4. So instead of having the square root only for x, we will have it as square root of the limit of x as x approaches 4. Again, we are doing this, or we are taking out the square root, or we are putting the square root outside of the limit expression so that we will be able to simplify the expression and we will be able to use the identity rule, which is like the easiest rule. So, because according to the identity rule, the answer will just be C, or this number here. Now, again, identity rule. This is your identity rule. According to the identity rule, answer here is 4. So that's simply square root of 4, or that is 2. Next example, we have the limit of cube root of x as x approaches negative 27. Again, instead of having the cube root of x, we will get the cube root of the limit of x. So that's the cube root of the limit of x as x approaches negative 27. Again, using the identity rule, answer for the expression inside this cube root is this number here, or that's negative 27. So that will simply be cube root of negative 27. So the cube root of negative 27, using your calculator there if you have one, answer is negative 3. And the third example, we have the limit of square root of x as x approaches 36. Again, that will become the square root of the limit of x as x approaches 36. Answer inside this radical sign is simply 36. So that will become square root of 36. So the square root of 36 is 6. So the answer for this one, limit of square root of x as x approaches 36 is 6. The next rule is called the constant multiple rule. So the constant multiple rule says that we have the limit of k times f of x as x approaches c. So what you will do here is that's k times the limit of f of x as x approaches c. Or in other words, the limit is equal to the limit of the function times the constant. Okay, so what we do is we take out the constant here in this function and we get the limit first, then multiply it to the constant. So to illustrate this clearly, let's have some examples. We have the limit of 5x as x approaches 3. Now, this is considered as a constant multiple because we are multiplying our function x by 5. So, we separate 5 and x. We take out 5, so that's 5, times the limit of x as x approaches 3. Again, we take out 5, okay, and we make it as our constant multiple. And we have to multiply it by the limit of x as x approaches 3. So, limit of x as x approaches 3 is simply 3 using our identity rule, and 5 times 3 is 15. So the answer to limit of 5x as x approaches 3 is 15. Next, example number 2, we have limit of negative 3x as x approaches 7. Again, our multiplier here is negative 3. So we take out our constant negative 3 and multiply it to the limit of x as x approaches 7. So the limit of x as x approaches 7 is simply 7 using our identity rule. So that's negative 3 times the answer here, which is 7. So that's negative 3 times 7, that is negative 21. So the limit of negative 3x as x approaches 7 is negative 21. Third example, we have limit of 4x squared as x approaches 5. Our constant multiplier here is 4. So we take out 4. That's 4. Limit of x squared as x approaches 5. Again, we take out 2 and make it as our exponent of the limit. So limit of x as x approaches 5, that's 5. So we have here squared, or our exponent here. So that's 4 times 5 squared. 5 squared is equal to 25. So that's 4 times 25, which will give you 100. So the limit of 4x squared as x approaches 5 is 100. The next limit law is called the sum and the difference rule. Basically, the sum and the difference rule are similar. So for the sum rule, it says that the limit of f of x plus g of x as x approaches c is equal to the limit of f of x as x approaches c plus the limit of g of x as x approaches c. So what we do here is we're trying to separate the addends, and we have to get their limits one by one. For the difference rule, okay, the only difference between sum and difference rule is the plus and the minus sign. Aside from that, they're basically similar. So for the difference rule, it says that the limit of f of x minus g of x as x approaches c is simply the limit of f of x as x approaches c minus the limit of g of x as x approaches c. So we just have to separate f of x, get the limit, then minus the limit of g of x. So, example, we have the limit of 4x plus 3 as x approaches 2. Again, the sum rule is applicable here because we see the plus sign in our expression. So, if you see the minus sign, of course, what's applicable there is the difference rule. If you see the plus and the minus sign, then you have to combine both the sum and the difference rule to solve your limit or to get the limit of the given function. So, let's go back to the example. Limit of 4x plus 3 as x approaches 2. So, we will separate 4x and 3 and get the limit of them and get the limit of these expressions one by one. So first, we take the limit of 4x as x approaches 2 plus we take the limit of 3 as x approaches 2. Again, we have to further simplify limit of 4x, so that will be 4 times the limit of x using the constant multiple rule, so that we will be able to get the limit of x. So we separate 4 and x, that's 4 limit of x as x approaches 2 plus the limit of 3 as x approaches 2. Now, take note that the limit of x as x approaches 2 is simply 2 using the identity rule. Then we multiply our constant multiple, which is 4, plus the limit of 3 as x approaches 2 using the constant rule. Okay, our limit should be 3. So that's 4 times limit of x as x approaches 2 is 2 plus limit of 3 as x approaches 2, answer there is 3. So we have 4 times 2 plus 3. So 4 times 2 is 8 plus 3. 8 plus 3, that's 11. So the limit of 4x plus 3 as x approaches 2 is 11. Okay, so that's the sum rule. And next we have the limit of x squared minus 2x plus 5 as x approaches negative 1. So take note, we now have the combination of the minus and the plus sign. So we will use the sum and the difference rule simultaneously. So again, we get the limit of each of the terms. So that's limit of x squared as x approaches negative 1 minus limit of the middle term, which is limit of 2x as x approaches negative 1 plus the limit of 5 as x approaches negative 1. Again, we can further simplify limit of x squared using our root rule and limit of 2x using our constant multiple rule. So limit of x squared will become limit of x as x approaches negative 1 squared because we're taking out the exponent minus the limit of 2x, we take out 2, and it will become our constant multiple or our multiplier. So that's 2 times the limit of x as x approaches negative 1 plus the limit of 5 as x approaches negative 1. Now, using the identity rule here, limit of x as x approaches negative 1 is negative 1. Then we have the exponent squared. Minus 2 times, again, limit of x as x approaches negative 1 is negative 1. Plus the limit of 5 as x approaches negative 1, that's 5. So again, this is negative 1, then squared, minus 2 times negative 1 plus 5. So negative 1 squared, that is 1, minus 2 times negative 1, that's negative 2, then plus 5. Again, negative 1 squared is positive 1, minus 2 times negative 1, that's negative 2, plus 5. So we simplify this. Take note, negative, we have the invisible 1 here. Negative 1 times negative 2, that will give you positive 2. So you will have 1 plus 2 plus 5. Okay, this one will become positive. So we have, instead of 1 minus negative 2 plus 5, we will have 1 plus 2 plus 5. So 1 plus 2, that's 3, plus 5, that will give you 8. So the limit of x squared minus 2x plus 5 as x approaches negative 1 is 8. Okay, we have the limit of 4x squared plus 5x minus 4 as x approaches negative 2. Again, we have a combination of plus and minus, so we will use the sum and the difference rule simultaneously. So again, we get the limit of each of the terms. That's limit of 4x squared as x approaches negative 2 plus the limit of 5x as x approaches negative 2 minus the limit of 4 because we have our third expression 4 as x approaches negative 2. So again, we could still simplify this and break this down. Also 5x. So we take out 4 as our constant multiple. We take out the exponent and we have 4 times the limit of x as x approaches negative 2 squared. Plus, we take out 5 as our constant multiple. That's 5 times limit of x as x approaches negative 2 minus limit of 4 as x approaches negative 2. Again, using the identity rule here and the constant multiple here. So we will now find the answer. Limit of x as x approaches negative 2 is negative 2 using the identity rule. So this is negative 2. So that's 4 times negative 2, then squared, plus 5 times, again, using the identity rule, answer here is negative 2. Minus limit of 4 as x approaches negative 2 using the constant rule, that is 4. So we have 4 times answer here, which is negative 2 squared, plus 5 times the answer here, which is negative 2, minus the limit here, which is 4. So negative 2 squared is 4. So we get 4 times 4 minus 5 times negative 2, that's negative 10, then minus 4. So 4 times 4, that's 16, minus 10, minus 4. 16 minus 10 is 6, minus 4, that's positive 2. So the limit of 4x squared plus 5x minus 4 as x approaches negative 2 is positive 2. Next, we will move to the next limit law, that is the product rule. Next, we will move to the next limit law, that is the product rule. According to the product rule, the limit of f of x times g of x as x approaches c is simply equal to limit of f of x as x approaches c times the limit of g of x as x approaches c. Or in other words, the product of, or the limit, in other words, the limit of the product of the function is equal to the product of each of the limit of the function. To express this clearly, let us have some examples. First, we have the limit of 2x minus 1 times x plus 1 as x approaches 0. Again, we have two factors here, 2x minus 1 and x plus 3. So to get the limit, we will get the limit of each of these factors. So we have limit of 2x minus 1 as x approaches 0 times the limit of x plus 3 as x approaches 0. Now 2x minus 1 could also still be broken down. That is limit of 2x as x approaches 0 minus the limit of 1 as x approaches 0 times x plus 3 could also be broken down into limit of x as x approaches 0 plus the limit of 3 as x approaches 0. So limit of 2x can still be broken down into 2 times the limit of x as x approaches 0. Then copy the rest of the terms in this equation. So take note, using the identity rule, limit of x as x approaches 0 is 0. So that's basically 2 times 0 minus the limit of 1 as x approaches 0 using the constant rule is 1. Then limit of x as x approaches 0 is 0 plus limit of 3 as x approaches 0 using the constant function, or the constant using the constant rule, is simply 3. So that is 2 times 0 minus 1 times 0 plus 3. So 2 times 0 is 0 minus 1 times 0 plus 3. 0 minus 1 is negative 1 and 0 plus 3 is positive 3. Negative 1 times positive 3 is equal to negative 3. So the limit of 2x minus 1 times x plus 3 as x approaches 0 is equal to negative 3. Next example, we have the limit of 3x plus 2 times negative 2x plus 3 as x approaches negative 2. So again, we take the limit, or we get the limit of each of the factors. So that's limit of 3x plus 2 as x approaches negative 2 times the limit of the other factor, negative 2x plus 3 as x approaches negative 2. Again, we can still break down 3x plus 2 and negative 2x plus 3 into simpler limits. So that's limit of 3x as x approaches negative 2 plus the limit of 2 as x approaches negative 2 times we have limit of negative 2x as x approaches negative 2 plus the limit of 3 as x approaches negative 2. So take note, 3x and negative 2x could still be broken down using the constant multiple rule. So we get 3 times the limit of x as x approaches negative 2. So we break down 3x into 3 times limit of x plus the limit of 2 as x approaches negative 2 times negative 2x again could be broken down into negative 2 times the limit of x as x approaches negative 2 plus limit of 3 as x approaches negative 2. So take note, this is 3 times the limit of x as x approaches negative 2 is negative 2 using the identity rule plus the limit of 2 as x approaches negative 2 is 2 using the constant rule. Then we have negative 2, so we have negative 2 here, times limit of x as x approaches negative 2. Again, using the identity rule, answer here is negative 2 plus limit of 3 as x approaches negative 2. Using the constant rule, that's 3. So we get 3 times negative 2 plus 2 times the quantity negative 2 times negative 2 plus 3. So negative 3, or sorry, that's 3. So 3 times negative 2 is negative 6 plus 2. Then the other factor is negative 2 times negative 2. That's positive 4 plus 3. So negative 6 plus 2 is equal to negative 4. And 4 plus 3 is equal to 7. So negative 4 times 7 is equal to negative 28. So the limit of 3x plus 2 times negative 2x plus 3 as x approaches negative 2 is negative 28. Let's now discuss the last limit law, which is the quotient rule. Now, according to the quotient rule, the limit of f of x over g of x as x approaches c is equal to the limit of f of x as x approaches c over the limit of g of x as x approaches c. So in short, we're simply getting the limit of f of x, then divide it by the limit of g of x. So take note, this quotient rule or this rule is true provided that the denominator is not equal to 0. So, example, we have the limit of x over x plus 2 as x approaches 3. So again, we get the limit of x as x approaches 3 over the limit of x plus 2 as x approaches 3. So we can still simplify the limit of x plus 2 and break down that into limit of x over x plus 3 over limit of x as x approaches 3 over limit of x as x approaches 3 plus limit of 2 as x approaches 3. Using the identity rule, limit of x as x approaches 3 is 3 over limit of x as x approaches 3 is 3 plus limit of 2 as x approaches 3 using the constant rule is 2. So that's 3 over 3 plus 2. So that will give you 3 over 5. So since we cannot simplify this further and this is the simplest form of the fraction, then the limit of x over x plus 2 as x approaches 3 is 3 over 5 or 3/5. Second, the limit of 2x minus 1 over x squared plus 2 as x approaches negative 1. Again, we take the limit of each of the numbers in the fraction. So that's the limit of 2x minus 1. So we break this down into 2 times the limit of x as x approaches negative 1 minus the limit of 1 as x approaches negative 1. For the denominator, we have the limit of x squared as x approaches negative 1 plus the limit of 2 as x approaches negative 1. So the limit of x as x approaches negative 1 using the identity rule is negative 1 minus the limit of 1 using constant rule, that's 1. Limit of x squared using the power rule, that's limit of x, which is as x approaches negative 1, that is negative 1. Then raise that to your exponent squared plus the limit of 2 using the constant rule is 2. So that's 2 times negative 1 minus 1 over negative 1 squared plus 2. So 2 times negative 1 is negative 2 minus 1 divided by negative 1 squared, that's negative 1 times negative 1, that's positive 1 plus 2. So negative 2 minus 1 will give you negative 3 divided by 1 plus 2, that is 3. So negative 3 divided by 3 is equal to negative 1. So the limit of 2x minus 1 over x squared plus 2 as x approaches negative 1 is negative 1. The last example, limit of x minus 3 over x plus 3 as x approaches negative 5. Again, we get the limit of each of the terms in the numerator and each of the terms in the denominator. So that's limit of x minus 3 as x approaches negative 5 divided by the limit of x plus 3 as x approaches negative 5. So we break this down into simpler limits. That is limit of x as x approaches negative 5 minus limit of 3 as x approaches negative 5 divided by the limit of x as x approaches negative 5 plus the limit of 3 as x approaches negative 5. Using our constant rule and our identity rule, limit of x as x approaches negative 5 is negative 5 minus limit of 3 is 3 divided by limit of x as x approaches negative 5 is negative 5 plus the limit of 3 as x approaches negative 5 is 3. So that's negative 5 minus 3 divided by negative 5 plus 3. So negative 5 minus 3 is negative 8 divided by negative 5 plus 3, that's negative 2. So negative 8 divided by negative 2 is positive 4. So limit of x minus 3 over x plus 3 as x approaches negative 5 is positive 4. So those are all our limit laws. We have the constant rule, we have the identity rule, the constant multiple rule, the power rule, the root rule, the sum rule, the difference rule, the product rule, and the quotient rule. So I'll see you in the next lesson. Bye!